Hi everyone, this video is on question 5 from exercise 9G of Pure 2. So it's another parametric differentiation question where we have to find the equation of the tangent line in part A. So as usual, when we want to find the equation of the tangent to a curve at a specific point, we need to find the gradient at that point and the coordinates of the point. So let's find the gradient first. Since it's parametric differentiation, we need to, when we have parametric equations, we need to use the parametric differentiation, which means we first need to find dx dt and then divide dt and then divide them. So dx dt is equal to e to the 2t. So the exponent is 2t. 2t differentiates to 2, and that comes down as the coefficient, and we have 2e to the power of 2t. And divide dt is similar. We have another exponential function. E to the t differentiates to 1, so you just have e to the t, and then you can find dy dx by doing dy dt divided by dx dt. This gives us e to the t divided by 2e to the power of 2t, and we have a half, and then e to the t minus 2t is e to the minus t. So that's the derivative in this case. Or we can also rewrite that as 1 over 2 times e to the t. So both of them basically work here. And we now need to find the coordinates of the point A. So remember that we have point A when t is equal to len 2. So that means we need to substitute len 2 into equations of x and y to get the coordinates. So for the when t is equal to len 2, x is equal to, so x is e to the 2t, so t in this case is len 2, 2 len, sorry, here is 2, not len t, len 2. So 2 times len 2, and this can be simplified, obviously, because of the exponential properties. This coefficient is the power of the number inside, and e and len cancel each other out, so we just get 4 for the x coordinates. And then for the y coordinates, we use e to the t minus 1, so e to the len 2 minus 1. So e and len cancel each other out, we get 2 minus 1, which is 1. So the coordinates of point A are 4 and 1. This is very important because we are going to use this and the gradient to find the equation. Just before we move on to finding the equation of the tangent line, we need to do one more thing with the gradient, because right now we have the gradient equation of the gradient, but we don't know the value of the gradient. So we just need to substitute t is equal to len 2 into the equation of the gradient. So when t is equal to len 2, then the gradient is equal to 1 over 2e, and then the power is t. T is len 2. So then let's simplify this. So again, e and len cancel each other out. So we are just going to have 2, which is 1 over 4. So this is the gradient. This is the value of the gradient at point A. Okay, now we have the gradient and the coordinates of the point. So we can use y minus y0 is equal to m times x minus x0 to find the equation of the line. y0 is 1, m is 1 over 4, which is the gradient, x0 is 4, so we can rearrange this. First, let's expand the bracket, so it's a quarter x times minus 1. Then rearranging that gives us just 1 over 4x. So this is the equation of the tangent line at point A. So yeah, this is the answer to part A. And part B is an interesting one. It says, show that the curve C has no stationary points. So we first need to ask ourselves, when do we have a stationary point or more than one? Basically, whenever the value of dy dx is equal to 0, and when you solve that equation and you get some values for the x, then those x values are the x coordinates of your stationary points. And now in this case, we need to find dy dx and then see what happens. So let's see. Dy dx is 1 over e to the 2t. So for part B, we know that dy dx is from part A 1 over 2 times e to the power of t. Okay, now if we want to find a stationary point, we need to find dy dx is equal to 0, which means 1 over 2e to the power of t is equal to 0. And we can rewrite the left-hand side as a half times e to the power of minus t is equal to 0. And there's a big problem with this one. We can first multiply both sides by 2 to just get rid of that. And we are going to get e to the minus t is equal to 0. And this is a huge problem because this doesn't exist. Like, you can't find the value for t such that when you raise e to that power, then you get 0. This is just not possible. So since it's a contradiction, e to the minus t can't be 0, then you can conclude that this equation doesn't have any solutions. Therefore, the stationary we don't have any stationary points. So the curve C doesn't have any stationary points because this equation doesn't have any solution. So no stationary points. Yeah, so that's it for this video, and thank you for watching.